All right, what's good, everybody? So, in this stream, I don't think this will be too long of a stream, but I'm gonna do get ready for. Khan Academy has a get ready for course, and so I'm betting that there's probably somebody watching this that's about to take calc. So I figure why not do the get ready for since we're about to start calc. So I'm gonna just do unit one test. I'm not gonna do the whole test. This test is 28 questions. I might do like I don't know, like a few, like 8 or so. I'll break it up into sections. But this test, it's all about. Let me see what's all on here first before I just go into it. But I think it's just like like just regular algebra stuff, evaluating functions, piecewise functions, composition of functions, factoring. Yeah, this is like basic algebra stuff. Trig, unit circle, trig, rational expression. So it's like an algebra 2 pre-calc esque test. So we're gonna take this and see how it goes, and I'll kind of teach slash remind as I go. But all right, let's see what it has us doing. So convert to radians. We can do that. Convert the angle theta equals 310 degrees to radians. Now, I've worked with people who have different ways of doing this. I have my preferred way. I know some people like to use a formula, but I do this. What are we converting? 310. All right, so here's how I do it. I just think of it in terms of like proportions. I know 310 degrees is out of like a whole 360 degrees, and I'm trying to figure out like what that radian equivalence is, and I'll call it X since I don't know it. Left side will be degrees and right side will be radians. So I'll label it so we know. And then if 360 degrees is like the full circle, in radians, you know that's 2 pi radians. So you can do it like that, or technically, I guess you can use like 1 pi and 180. I guess if it makes the number smaller, either way. But I just do that and then solve for x. So that's what I'm about to do. Let's see. Do they make it? Let's see. Yeah, let's do a calculator. So we're doing 310 over 360. I don't think it keeps it as a fraction for us. I guess I could have used Desmos or did it by hand, but I don't feel like doing that. Yeah, I'm gonna just Desmos it. We have what, 310 over 360, and then as a fraction 31. Now that's it. I would have thought it did more than that. 31 over 36, and then that is equal to x over 2 pi. And then I'm just going to cross multiply real quick. So I got boom equals 31 times 2 pi. And then just divide both sides by 36, and then that'll be the radian equivalent. So what's that? 62 over 36 pi. So I don't think they'll make us simplify it. I don't really care about that, to be honest with you. So wait, what do we get? 62 over 36 pi over 36 pi. Okay, bet. Not that bad. All right, hopefully we can go 28 for 28. This one should be super easy. Find sine of beta. Okay, sine is what? Opposite over hypotenuse if we use SOHCAHTOA. So if beta is our reference angle, opposite is 15, hypotenuse is 17. I'll go D. Not that bad. Okay. I guess it just wants us to evaluate functions. Can I write on here? Let me see. No, that's trash. That tool is not the best. But anyways, -6 times f of 3. F is the blue. F of 3 looks like what? -2? -2. So -6 times -2. Let me write this out. -6 times -2. Boom. And then we got -6 times g of -1. G of -1 is just the y value whenever x is -1, and it looks like that y value is 6. So -6 times 6, I'm gonna just put minus, well, I'll write what it is. I was gonna say minus 36. So that's just what, 12 minus 36. Are we typing in our answer? Yes. What is 12 minus 36? 36 minus 12 is what, 24? Negative 24, I'm thinking. Okay. Unit circle, let's see. Of the following unit circle, theta is in radians. Which two of the following expressions is equivalent to tangent of theta? All right, so if that's theta, I know tangent is what, y over x. Oh, they just have expressions. All right, let's see here. So I remember there being a property that says something about like tangent of theta equals tangent of negative theta. It's one of these. I don't remember which one it is. Let's just see if we can figure it out. All right, so tangent of theta is what? The y value over the x value. So the y value is negative, the x value is negative, so that should be a positive result. Tangent of 2 pi plus theta. I feel like this one has to be one of them because any angle plus 2 pi, you're just going to land in the same spot. So that's my logic on that one. Let's see. I'm going to just go through each one. Actually, because if you add pi, that's just going like halfway around the circle. So I was looking at answer choice B, but if I do, I'm going to look at C real quick. If I go whatever theta is, and then I add pi to that, then that's me adding half the circle. So I would end up right around here. So x and y are both positive. So the result is positive again. So it might be C. Because actually, hold on. Let's see. If you do pi, and then it's like, yeah, no, that should keep it positive. Let me try D real quick. If I do pi and then I go the other way, that would put me in a different quadrant. And then, so D I think is wrong. B, if I go negative theta, so that's like, boom, and then some, that would also put me in quadrant 2. Not also, but that would be in a wrong quadrant. So I think I'm going to go A and C. Those are my two answers. Let's go. I got sounds for this. Let's go. All right. This one is too good to be true, bro. Do I have any viewers in here? Hold up. How do I see how many viewers I got? Or can I even see that information? I don't even know. I'm going to figure out sooner or later. But anyways, this one's easy. They give us some function k of t. They want k of 3. I'm going to just replace t with 3. 13 times 3 is what? 13, 26, 39 minus 2, 37. Let's go. All right. Adriel tried to perform the following division and reduce to lowest terms. Okay, bet. So boom. Here's his work. Rewrote the dividend. Okay, how do you rewrite it? Oh, he factored out a negative sign. Hold up. So negative x. Okay, I already see where the mistake is. He factored in the dividend, which is like the thing that comes first. The numerator is wrong. The denominator looks good. But up top, this is why I always tell my students to check their work whenever they factor. So if I distributed that negative sign, it would give me a negative x, but then that would give me a minus 1, whereas we want a negative x plus 1. So if this is going to be a what mistake? Yeah. The mistake is something about the dividend is wrong. Yeah. Okay, bet. All right. Next question. Consider the following rational function f in behavior. All right. So I'm just going to look at the highest exponent term in both the numerator and denominator and then see what happens. So the biggest term up top is a negative 8x cubed divided by a 2x squared. I feel like that's worthy of being written down. So what number is this? Number 7. So look, I'm going to go highest power up top divided by highest power on bottom to kind of simplify and then just see what's happening. Like as x gets bigger and bigger or smaller and smaller. Let's see. So I'm going to go negative 8x cubed over 2x squared. Negative 8x cubed over 2x squared. Okay, what does that become? Negative 8 over 2 is what? Negative 4. And then x cubed over x squared just becomes x if I subtract my exponents. That's an exponent property reminder just in case somebody forgot. Whenever the same base is being divided, you just subtract the exponents. 3 minus 2 is 1. I could have put a 1 right here if I wanted to. But so if I look at the expression negative 4x, as x gets bigger, let me see what happens. Like I'm thinking about like negative 4 times 10 compared to like negative 4 times 100. It's getting more negative, I'll say that. And then, so that's when x is getting closer and closer to infinity. So I think that's an answer choice. As x is closer to infinity, this one gets smaller and smaller because the number gets more and more negative. And I think the opposite is true. Not I think, it has to be true, because if x is getting smaller and smaller, think more and more negative, that'll be a negative times a negative, which is a positive. So it'll get really positive. That's my logic. Let's go. What is their logic? Yeah, so they did the same thing. They took biggest term up top divided by biggest term on bottom, simplified it down to a negative 4x. And then, yeah, that negative 4x expression, you got to see what that does as x gets bigger and bigger and smaller and smaller. All right. We might go to like number 10 or something like that. And then we'll probably get back on another time tomorrow. Factoring. Okay, this one shouldn't be too bad. Let me write this down. 64x squared minus 144x plus 81. I like switching back and forth like this because I'm gonna try to get my my short-term memory back in check. Or not back in check, in check. It's never been in check. So let me see. 64x squared minus 144x plus 81. 64x squared minus 144x minus, was it 81? Plus 81, dang it. Was it minus 144x? Okay, bet. 64x squared. Okay, so me personally, first thing I'm noticing is everything is like perfect squares. Everything is a perfect square. Perfect square trinomial. That's like one factor method that I feel like I sleep on. I don't know why, to be honest with you. I'm trying to remember, because perfect square trinomial is, I want to say like this, or such that it can be written like this. Maybe. Let me see, but then there would have to be coefficients though. Or, I don't remember. I'm going to look it up. But just from looking at it, I think this has to be something with an 8 right here. And then maybe something with a 9. I'm not sure. Because I can't do double 9s right here. I wonder if there's a way to do it like without just using a perfect square recognition. Because slide and divide is definitely not going to happen. I wonder if I could do it like this, if it'll help. Since I'm realizing that they're all perfect squares, I wonder if I can go like this. Minus, not 7, 12, squared x plus 81. All right, so that's something. Hence the 8 and the 9. But for the 12, I don't remember, bro. I gotta look up. I gotta add this to the flashcards. Perfect square trinomial. I have a calculus flashcard. I low key want to make. Ooh, you know what? I'm gonna do this. I'm gonna call it audible, and I'm gonna make a. I'm gonna make a flashcards document for something other than calc. So here's what I'm gonna do. I'm gonna have calc flashcards, and then I'm gonna have like. Do I want to go algebra? I'm gonna call it like below calc, or something like that. I don't know. I don't know what I'm gonna call it yet, but that's what I'm gonna do. I'm gonna make a copy of this real quick. How do I make a copy? Make a copy. I'm gonna call this below calc flashcards. And then in my drive, I wanna go. Let's do. I don't know. I'm gonna just put it in here. I'll figure it out later. All right, and then this one I'm gonna call it calc flashcards. Actually, more specifically, we'll call it calc AB flashcards. All right, so that's that. So this one, I'm gonna just take them out. Actually, some of this stuff I can keep on here. Continuity, I don't need that. I'm gonna change these up as I go. So what I want to do here is perfect square trinomial. I don't know which side I want to put as which, but let me figure out what it is first. All right, let's see. Like this. Or I need something with some coefficients. That's what I need. Should I type that in? Is that much of a difference maker? Okay, so it's, yeah, it is something times itself. Okay. So 8 and 8, 64, 3 and 3. Does that guarantee to work for any? Is it just like that? Hold on, let me see. So if I go 8 and 8 here, and then I would have to go -9. Is that just guaranteed? Is that what it is? And it just always works? Let me see. Hold on, let me fix this. That looks bad. All right, hold on. Let me find out. It's that easy. So if I test this, first will be 64x squared. Outer, oh yeah, because outer would be -72x, and then the inner would obviously also be -72x plus 81. Oh, I mean, I don't even know if that's worth flashcarding. So I guess I should have just went with my initial thought, and it actually does end up being what we needed to be. Okay, so bet 8x minus 9 squared. Say less. -9, boom, squared. Yeah. Oh, okay. A squared minus 2. I guess that's worthy of being written down. A squared minus 2ab. Yeah, because that's what we need to recognize. A squared. Let me insert a formula. What am I trying to do? Am I tweaking? I'm gonna just copy one. Dang, it won't let me copy a formula. Okay. It was what? A squared plus 2ab plus b squared. We got to think about what that, if that matters, if there's minus signs in there. Why won't it let me insert a formula? Oh well. All right, that's just a plus b squared. All right, easy enough. Okay, so that was like extra for no reason. All right, let's see. What number are we on? 9 of 28. Bit. Okay, so Avery was trying to factor for She found that the greatest common factor of these terms was 4 and made an area model. What is the width? Okay, I remember doing this on an algebra assignment. So it's 4x squared plus 20x minus 16. 4x squared plus 20x minus 16. 4x squared plus 20x minus 16. I do agree with her in that the greatest common factor is a 4. So they just want us to get the inside part. So that should be easy. X squared plus 5x minus 4. Do they want us to factor some more? Do we even, is that even neg 2? No, it's not even possible. All right, so what do we get? X squared plus 5x minus 4. X squared plus 5x minus 4. Double check. X squared plus 5x minus 4. Okay, bet. All right. This one, it looks like we're dealing with some rational expression. Answer 2 questions about the following rational expression. Okay, what is an equivalent expression in lowest terms? Okay, let me try something real quick. Actually, you know what? No, I'm going to keep testing my memory. I was going to side by side it. That last one was number 9. Here's 10. I think this was 8. Or no. Okay. So the expression was 4x. Oops. I'm tweaking. 4x minus 32 over x squared minus 64. 4x minus 32 over x squared minus 64. Obviously, we're going to factor. GCF up top. Difference of squares on bottom. Plus and minus. Difference of squares, I always say, is the easiest one once you recognize it. Up top, I think a 4 can go into both of those. 4 times what? 4 times 6 is 24. 4 times 7 is 28. So 4 times 8 must be 32. X minus 8's cancel. So you're left with 4 over x plus 8. So remember from Algebra 2 and graphing these, whenever something cancels out, there's a hole. Or if you want to be fancy, you can call it a removable discontinuity. But what do we have? 4 over x plus 8. That's what I'm getting. 4 over x plus 8. What values of x must we exclude from the domains of the expressions? I always say this. If it's rational, the domain restrictions are just whatever is not allowed. So if you're talking fractions, what's not allowed? A 0 on bottom. So just think about what x values will cause that to happen. If x was either negative 8 or positive 8, then you would be dividing by 0. So that's why those numbers are not in the domain. So my answer choice should be something like a plus and minus 8. All right. And then, yeah, that should be it. Okay, bet. All right, piecewise. F of whatever. Which branch we use. Oh, by the way, random fact, in case anybody was wondering. In case you want to know what to call these 3 like pieces, I looked it up. Apparently, they're called branches. Just in case you didn't know. I just learned that like a few months ago. But anyways, which branch you use depends on what x value you're dealing with. So right now they want us to evaluate f of 2. So I just look and see like which branch does 2 fit in. This first one says t equals 8, and we know that's not true because t equals 2. Same thing for the middle branch. And then this third branch says that t is not 8 or 10. And 2 is not 8 and 2 is not 10. So that bottom branch is what I'm going to be using. I'm literally just going to replace t with 2. So that'll be, instead of t squared, that'll be 2 squared, which is 4. I'm going to type this out and then simplify it. So then minus 3 times 2 is 6. And then plus 2. So whatever that is, 4 minus 6 is what? Negative 2. Negative 2 plus 2 is 0. All right, bet. Okay. The measure of triangle RST are in radians. Okay, bet. What is the value of cosine of pi over 4? Okay, well, here's pi over 4, our reference angle. Cosine, we know, is what? Adjacent over hypotenuse. And they only give us the opposite. So we don't know adjacent, we don't know hypotenuse. So we got to find them using trig. All right, let's see. So, or, yeah, I was going to say, I wonder if we can just do this like from straight knowledge, but I guess I'll use the triangle, I guess, so as not to like ruin the, what do you call it? The credibility of the problem. So I guess what I would do if I didn't know that, I think I kind of just have to use that kind of knowledge, because I was going to say, do like sine of pi over 4 equals 3 over hypotenuse. And then you can use that to solve for hypotenuse. And then because it's a right triangle, you can go Pythagorean theorem to solve for side TS. I guess we could do it that way. Let's try it. I'm going to side by side just for a little bit. Hopefully y'all can still see this. But for number 12, here's what I'm going to do. Because we know cosine is like adjacent over hypotenuse, neither of which we have. So I'm just approaching it from that lens, is that we got to find adjacent and hypotenuse first. So what I would do is use what I have, which is the opposite. And I know sine is associated with opposite. So I could say sine of pi over 4 equals our opposite, which is 3 over, I guess I'll call it little t, because usually if capital T is the angle, then the side across from it is like the lowercase version of that. So I'm going to do that, and then I'm going to use that to solve for t, which is the hypotenuse. And then from there, I can solve, I guess, for little r is what we'll call it. All right, so I'm going to cross multiply t times sine of pi over 4 equals 3 times 1, which is 3. And then I'm going to divide by sine of pi over 4 on both sides. So, boom. All right. That is what we can do to solve for t. I'm gonna Desmos it. I keep forgetting I have a whole calculator right here. It's 3 over sine of pi over 4. What does Desmos tell us that is? That, I don't like the way that looks. Because what is sine of pi over 4? Root 2 over 2. If we did it like that, let's just check to make sure. Oops. No. Okay, so you can see those values are the same, so that's good. If I keep change flipped, that'd be what, 6 over root 2. And then just for review's sake, I can rationalize my denominator to make it say 6 root 2 over root 2 squared is just 2. 6 over 2 makes a 3. So I can go 3 root 2. That right there is the hypotenuse. And then from there, I can use that to solve for my side r. So let's use Pythagorean theorem since we got two sides of a right triangle. And one of the legs I know is 3. Plus the other leg we're trying to find, we'll call it little r. And then t we said was 3 root 2. So we'll just plug those into Pythagorean theorem and then use that to solve for r. So that's 9 plus r squared equals, if I square both of these, that'll be 9. And then root 2 squared is 2. So 9 times 2 will give me 18. Subtract 9 from both sides. I got r squared equals 9. And then r equals 3. Okay, so I'm glad we did that, because that after getting that answer, I shouldn't be too surprised, because pi over 4, we should know that that's 45 degrees, which makes this a 45 degree triangle, which means our legs are the same, making it a what? Right isosceles triangle. Just throwing out some reminders there. But okay, so now that we know all 3 sides technically, we can now get what we want, which is cosine of pi over 4, which this should be root 2 over 2. Let's see if that's what we get. Cosine is what? Adjacent over hypotenuse. And we just found out that our adjacent is 3. And then our hypotenuse was 3 root 2. So if I cancel out my 3's, I get a 1 on top, not a 0, and a root 2 on bottom. And then since we don't like radicals in the denominator, I can rationalize my denominator like so to get a square root of 2 on top and a 2 on bottom, which is exactly what we anticipated. Square root of 2 over 2. That was the biggest run around, beat around the bush during something that we should just know off of memory, to be honest. Root 2 over 2. That is correct. All right, I'm going to do one more. That way we could be halfway. And then I'll do the other half probably tomorrow at some point in the morning / evening. I got to see if I have any viewers in here real quick. Hold up. I got Twitch, but is there a Twitch manager app is my question. Or you can just do it within the app bit. Okay, cool. All right, let's do one more. So we got a rational. We're probably, not probably, we are going to end up factoring the denominator. So let's go ahead and do that before anything, because they're talking about vertical asymptotes. And you see how I called them holes, but look what they call them. Removable discontinuities. Once you get into that pre-cal and up level, they start to get fancier with their dialect. But all right, let's see if we can do something with that rational. So that's x plus 3 over x squared plus 2x minus 3. X squared plus 2x minus 3. X squared plus 2x minus 3. What was on top? X, was it an x minus 3? X plus 3, I'm selling. All right, this is number, what, 14, I believe? All right, so if we were to factor this, obviously we can't factor up top. So I'm going to leave that as is. On bottom, 2 numbers that multiply to -3 but add up to 2. I'm thinking 3 and -1. So I will factor that like so. Just to check, 3 times -1 is -3. 3 minus 1 is indeed 2. X plus 3's cancel. You have a 1 on top, not a 0. And then an x minus 1 on bottom. So there is a whole, or no, there is a removable discontinuity at what? X equals -3. And then there's a vertical asymptote at x equals 1. All right, so let's see. At -3, we said there was a removable discontinuity. At x equals 1, we said there was a vertical asymptote. Just to double check. Cancellation on the x plus 3's, and then 1 minus 1 on bottom will give me 0. All right, bet. Okay, that's not that bad, bro. The second half should be just as slight, to be honest with you. I'm not even gonna hit next because I don't wanna get tempted to do it. But first half of the test done. Let me look and show y'all what's in store. So we're halfway through this test right here. And then honestly, low key, I was gonna delve out of calc and do like another get ready for low key. Maybe like get ready for pre-cal or algebra 2. Which one am I most behind on? Pre-cal? Oh, stats. I could do stats. I'm honestly down for stats. But either that or probably pre-cal I'll do after we finish this unit test. Does it save my progress? Oh, I'm gonna act like I didn't see it. Factor in a trinomial. We'll remember that for next time. But also just for like record keeping sake, all these links that I'm using, like these Google Docs and stuff, I'm gonna make available to y'all if enough people want them. This one I'm gonna call it the sub calc flashcard document. So everything below calculus. This is gonna be an ultimate flashcard list, bro. All right, but anyways, I'm gonna make those available, and then also these notes that I do work on. I use OneNote. I'm sure y'all know what that is, but I like it because it's like PC and Mac compatible, and you can get it on like any device. And if you download the app, I can make these shareable so you can just pull up my notes on your phone or tablet or whatever y'all got. So I'm gonna do that. But next time we'll finish this unit 1 or get ready for unit 1 tests. And if anybody have any parting words in the chat before we get off? Oh, I need a cricket sound. Let me go through all my sounds too real quick. So I got this one whenever we do something good. Whenever we pass the mission. And then whenever like we go out sad. Or whenever we do something right. I like that one. And then, hey, nothing more needs to be said on that one. But with that being said, all right, I'm going to catch y'all on tomorrow. Peace.